Hello, Fernando. Hello, Tao Young. Welcome back here to Azure.
Hey
We're
guys.
going.
Hello, George. Hello, Tao. Welcome
Hey,
back.
thanks
Yeah,
for
yeah.
having me
Great to
again.
have you back here. Great to have you back.
So today we'll have something about the Bicep, the new ARM, the replacement from the ARM template, or it is not
Bicep.
the Bicep. This will be a replacement from the ARM templates. What are the news? And is it better than Terraform?
It's different. That's what I can say. The syntax might look very similar, but under the hood, it's different. So what we're going to discuss today is based on George and myself have been working with Terraform for the last 7 months. So I want to do a comparison between Bicep and the Terraform.
Yeah,
And
that's
what
a
are the
great.
pros and cons for both?
I think that's the perfect timing. I think 2021 Bicep is coming. I think for the first, production supported version very soon, if not already. And let's understand what's coming and there are modules now. There are a few things that I can deploy in multiple resource groups, and Tao is going to go through all these things that Bicep become as 0.1 version, and now is on version
2, I think.
0.2.
2 something, yeah.
Yeah, and 0.3 will be the first version that will be supported, and that's coming, I think, very soon. Then I think that's the perfect timing. That's all yours, Tao. If you want to share your screen and show us what you're playing. And
Yep. Let me share my screen.
don't forget to support us and subscribe the channel here. There's a lot of series about Azure Data Factory, Azure Monitoring with Tao. There's a lot of content about containers, Windows Subsystem for Linux. More than 60 videos published. Just follow us and please give us feedback and join us.
Cool. Okay, let's get started. So today I want to talk about the differences between Bicep and the Terraform. By doing so, what I've done is I've created a pattern which consists of a resource group, and in the resource group I have a key vault with and then some various secrets. I have a storage account for SQL backups, and I have a Windows VM running SQL Server, and then I have a SQL virtual machine resource. And within that SQL virtual machine resource, I configure things like SQL license edition, ports, SQL login, and then automated backup to the storage account. And most importantly, the drive configurations for the SQL machine. And then after that, I also have another resource that extend the disk configuration for the SQL for the existing SQL VM. So this is something that George and I have seen in real life in our custom we're working on right now. So at the custom site, something that been requested for us to implement, although it's not like 100% the same to what we implemented at the customer solution. But this is very similar to we're very similar to what we've done just over the last month or so. So to compare Bicep and Terraform, I've created this pattern in both Bicep and the Terraform. I'm going to go through the pros and cons, the limitations for using each language. Okay, so let's get started. To start it, let's go through the Terraform first. This is the Terraform template. By the way, I'm going to make this the templates I've written available to George, and we'll have the link in the description later.
So just an introduction for someone that never saw what Bicep is. Like in a sentence, what's Bicep?
So Bicep is a DSL for ARM. So basically, when you write a Bicep, customers been complaining that the syntax for ARM template can be very complex. So what Microsoft has done is they create this abstraction on top of ARM template with a simplified syntax. And then when you write a Bicep, a template, and then you actually under the hood, when you build it, it converts it back to an ARM template. And I think Microsoft is also working on converting, the capability of converting an existing ARM template into Bicep. And I think it's on their roadmap that is going to allow you to submit a Bicep template and then get deployed directly. But right now, when you write the Bicep template, you still need to build it, which is the conversion process that converts that to a ARM template, and then you deploy that. So basically, it's a simplified template for ARM, and it's natively from Microsoft.
Yeah, Otto, and we could say that if you compare with like TypeScript and JavaScript, it's like a transpile from one DSL.
That's right. That's right.
To the other one, and you write in Bicep, they transpile to native ARM, and then you run as a normal ARM template, and that bring more flexibility in a language that will be less code.
Yeah, it's a lot easier to write Bicep than ARM, that's for sure.
Yep, that's great.
Okay, all right. So let's quickly go through the Terraform first. So in Terraform, you have this block called locals, which is, you define like a value, name, a value pair, like locally stored in the template. If you compare that to Bicep, it's equivalent to the variables in an ARM template or in Bicep. But then you also have, I also have variables that I need to pass in to the Terraform template, and in here is called variable in Terraform. But if you look at Bicep or ARM, when you want to pass variables at the runtime, and it is called parameters. So a variable in Terraform is equivalent to a parameter in Bicep or ARM, whereas the local is in Terraform is very similar or equivalent to the variables in in Bicep or ARM. So that's something, and then also you have like both languages have an output, then that's the same. So I have a variable defined that I need to pass on a on-prem IP range. I'm going to discuss that what's going to be used later, but then everything else is defined. All the values is defined in the locals, right? So I have the subnet name, the VNet name, location, resource group name, VM size, etc. Everything defined in here. And you can have like strings, or you can have like a complex like a type. I think in a object where in Terraform is called a map, right? So then I can have an array of maps defining the VM data disks, etc. The VM configuration, SQL configuration that can also be placed as an object, and then and you have the data block in Terraform, which is you can use that to query existing resources. For example, I'm using the data block for Azure RM client config. So basically, using this one, I can get the current login ID, the current login session for my Azure subscription. I can get stuff like the username, the username, the tenant ID, subscription ID, etc., etc. I can look up existing resources. For example, I can look up a VM subnet by giving the resource group name for the VNet and the VNet name and the subnet name. I can look it up. This is something pre-existing, but I look it up and then I retrieve the properties of this resource. I'm going to be used that later on when I deploy resources that are related on that. And then later on, so firstly, I'll create a resource group, and then I generate random passwords. So if I can just stop here for a bit. So you see the resource group, Azure IAM resource group. This resource is defined in a provider. A provider is like you have multiple providers for Terraform, because Terraform you can deploy resources to multiple cloud platforms and other other targets. So we have a resource provider called a provider called Azure IAM. So basically, this is the one that you use to deploy stuff to your Azure subscriptions, and then you have other providers like AWS, or if you want to create users in Azure AD, then you have Azure AD provider as well, so on and so forth. So this is the resource group, the provider for creating a resource. Sorry. Yep.
I think before I go forward on that, there are three things there that I saw. Okay.
Yep.
You talk about locals.
Yep.
You talk about data, and you talk about provider.
Yep.
If you try to focus more like on Bicep, okay, and just compare with, if you try to look the code from Bicep and forget about a little bit about Terraform and focus on Bicep and just compare.
Yep.
How can we, if you scroll up a little bit on your Terraform side, you're defining locals here.
Yep.
One of the main things that people are using in Terraform locals are expressions, okay? It's like we do in ARM templates. We have the parameter. Then when you define the variable on ARM or Bicep, we concatenate things, we, combine things. Can we do the same here on Bicep?
Yes.
Okay.
So you just define a variable like here,
and you can use an expression, concat, you can use.
Yes. So with Bicep, as long as the function is available in ARM, you can directly call that function in Bicep.
Okay, then that should be similar to ARM and similar to locals. And I haven't seen the data. Can you do the data on Bicep as well?
No.
Okay.
Oh, well, it depends what you want to retrieve, right? You can do like resource. You can, there's ARM function to look up like resources or resource IDs for that, because you can directly call those functions in here, but really depending on what you want to retrieve, right? So what you can get out of the resource function in ARM is different for each resource group. It's different for each resource provider, each resource types. So really, if you can do that in ARM, then you can do that in Bicep. But
you still can use like the normal ARM resource to load something to get the by ID, and it's still
correct.
You still can do same. Okay, then that's data.
Yeah.
But the provider, we don't have that in Bicep, because provider is something very Terraform centric.
Yeah, provider is something that, because Terraform, is a you can use Terraform to deploy to more. Terraform is not only bound to ARM, Azure, right? So, but Bicep is. So this is something that you keep in mind. Bicep is only for Azure, and Microsoft has no plans to extend Bicep to other platforms.
Yeah, just for people to understand, provide on Terraform is anything that has an API that you can write, like a code that can call this API.
Yeah.
You could expose that on the HCL. That's the domain specific language for Terraform.
Yep.
But it's not the same on Bicep. Bicep, that's not extensible yet. Maybe in the future, we don't know. We don't even know. Maybe that can grow legs in the future, but there is no plans at the moment to create anything like Terraform provider. Like in Terraform, you can even extend and do something even just for your company, or it's not the same on here. We just doing a DSL on top of ARM.
Yeah,
that's great. That sounds good. Keep going.
Okay. All right. So the reason I want to touch on provider is that you see that I'm creating a resource group for resource group in my subscription using this resource, which is defined in the Azure RM provider in Terraform. I also have this random password resource, which is defined in another provider called random. So I need to define that in Terraform as well. Normally we have like a providers.tf block. So therefore I'm using this random provider to generate the passwords I needed for this template, which I'm going to get to later on. That's something that you can't do natively in Bicep. There are ways to generate random strings in ARM or Bicep using ARM functions, but I'm going to get to that later on when I touch the Bicep language template, and then explain why it's not a good idea to actually use those functions to generate passwords. And then I generate another like a random string as a name suffix. So a suffix are append to the end of the Sql VMs or the Azure VMs and key vaults and so on. So it's different every time when you use the template. And then I'll create a key vault. As you can see, the key vault name, I'll have the key vault name prefix, which is defined in local, and then I have append a suffix, which is the result of this random string block, right? And then in the key vault, I'll create an access policy. I'll give the current object, the current security principal I'm using to deploy the template. I'll give that access, give some permissions to be able to create secrets. I need this later on in order to create a secrets into the key vault. Otherwise, the ID I'm using right now, which is a service principal, I won't have access to actually write to key vault. And also to secure my key vault, I'm creating. I'm enabling the service endpoint only allowing the on-prem IP ranges, which is like an input parameter or variable in this case, are passed in. So only allow access from these IP ranges. As you can see, this is defined here. So when I apply Terraform template, I either need to specify the value for this variable like in the command, because I don't have a default value defined. Or what I can do is I can create a terraform.tfvars file, which is the default name for a variable for the variable file, right? So this is where you can define the value for the variables you define, right? So in order not to disclose the real IP of my public IP for my home, what I've done is, I just create like a /8 block. My IP is somewhere in here, right? So so if you look at the terraform.tfr file, is similar. Well, it's the same to the parameter files when you use ARM template. Okay, and then I'll create the secrets, which the value of these two secrets, the VM admin password and the SQL admin password are actually, what's been generated from the random block, right? And also I'll store the VM admin name and the SQL admin name in keyboard as well, and that's defined in locals. And then moving on, I'll start creating the VMs. So create the NIC first, and then I'll create the Windows VM. And in the Windows VM, I have a dynamic block which contains all the data disks, which is defined in the local. So in here, I have this statement say if the local data disk value is null, then I have this block is going to be an empty array. Otherwise, it's going to be this. So this creates the data disk defined in here. So can be one or more data disks defined in here. I have all this defined, right? So 1, 2, 3, 4, 5, 6, 7 data disks defined in here. Yep.
Can you do anything like that on Bicep? Can you do that kind of dynamic blocks?
Yeah. It's actually easier than in Bicep. I just passed on that. Yes, you can do that.
Okay, if you can show later, yeah.
So defining the OS profile, and then after the SQL VM is created, I'll create the Windows VM. After Windows VM is created, I'll create the SQL VM. As you can see that because I'm passing the virtual machine ID as the output of the Windows VM block, right? So this Terraform will automatically create a dependency for this, so it knows that this SQL VM will not be deployed before the Windows VM, right? So in ARM template, you have to specifically define the dependencies between these two resources, but in Terraform you don't have to, and the same in Bicep. As long as you pass in something like this to the Bicep code, Bicep will understand there's a dependency. So when Bicep generate the ARM template, the dependency will be added to here.
That's a great improvement, I think, to Bicep.
Yeah.
Compare with ARM template, then you're going to figure out the dependence for you and removes a lot of code already.
Yeah. So for this SQL VM resource, I'll do things like SQL license type, port, username, password. I do the storage, which means that this resource will actually configure, create like storage pools in Windows OS for the data and the log disks or the temp DBs. What it can't do in one scenario we have at customer side is automated backup to a storage account. This feature has not been implemented in the Azure RM provider in Terraform. So if you use native Terraform code, you can't do that. At least for when I checked about 5 days ago when I created the code, it's still the case. So I can't actually do that natively in Terraform. So to get away with that, for things that you can't do in Terraform natively, there are options that you can probably create a provisioner to use a script to create the resources, or you can actually wrap a ARM template into Terraform and deploy that way as well. but we're not going to cover that. But just to keep in mind the things that you can do natively in ARM or Bicep, but you can't do in Terraform because it's a third party, right? So so the other thing is that we had requirements that, you know, when you create a Sql VM, if you didn't create enough disks or disk space for the SQL data log or temp.db drives, you want to be able to extend the drives, the logical drives for those volumes later on. By doing that, you can actually add additional disks into the storage pool that for SQL data and the log drives, for example. This is something that, although the resource, there is a SQL VM resource defined in Terraform, this is something that you cannot do if the SQL VM itself is created in the same template, right? Because you're basically defining the same resource types, right? And with the same name, with the same ID. So that's something that you cannot do in Terraform. I don't think there's a way to get around that using the native resource Terraform resources. Although it's similar to, like, this constraint is similar to Bicep. If I create these two resources in the same template, I'm going to have the same issue, but I'll show you later how I got around that, implement this natively using Terraform by using nested templates. So, okay. So this is what Terraform has done. As you can see, I just quickly did a Terraform apply before we started recording. And to start, like, I do a Terraform plan. It shows me all these resources will be created, right? And I look at it and say, hey, everything is okay, no errors. Then I issue another plan, another command called Terraform apply / auto approve. So this is going to just go ahead and deploy this template. And after a few minutes, it says apply completed, and resources are all being created. So if I do a Terraform plan again, it will show me this is comparing the resources that's been recorded in the Terraform state file, and say, there's no change, so nothing is going to be deployed if I run Terraform apply again, and then that's it for Terraform. A few things I want to point out here. Terraform state can be, can be hard to maintain. We've seen situations where, like, the corrupted template state file, or the Terraform, you have a Terraform version that recorded in the Terraform state. So if there's a version mismatch, say, for example, if I initially deploy that Terraform template using version 0.13, and then did some changes on another computer running Terraform 0.14, and then it's going to update this Terraform version. And then if I jump back to the old machine running 0.13, then I won't be able to use that machine to deploy or make changes, because the version is lower than what's recorded here, and this has caused me troubles in the past. And then the other thing is that everything, based on what you've seen, I haven't done anything wrong. I did not create, I did not hard code or the password. I use a random provider to generate the random password, etc., and then put in the key vault and doing all the right thing. But if I just go search for the state file, you can see that although I did not specify it in the template, but the output for the random block is actually stored in clear text.
Yes, Talbot, this is clear on the Terraform documentation. And one reason we use like a remote backend is to use the encryption. Like you can use this in an encrypted blob storage, and you can have control version. And even more on the blob storage, you can have a resource lock. And if you are deploying a thing, while you are deploying, your colleagues can't deploy.
Yeah, but still, like, you know, I can secure. My argument is I can secure my key vault, whatever. So if I don't secure my Terraform state, or you know, other people has got access to my Terraform state, I can actually go in here, and then I don't actually have to go to key vault to get a password. I can just look up the Terraform state. So this is another attack surface, right? This is something that you need to consider. If you do things like that, you make sure you need to secure your Terraform state file, and make sure you don't check in your Terraform state in your GitHub.
Yeah, you're right.
So just want to point out here, it is actually stored in. This is the same for Terraform Enterprise. If I go to the Terraform Enterprise workspace, and then I can look at the state file, and then I can export it as a clear text. I can do whatever I want, right? So, yeah. So just some observation here.
Tao, I want to see what Bicep can do, mate.
Yep.
Show me
so
Bicep.
enough about Terraform. Let's go Bicep. So the latest version of Bicep, if I have a look at here, is 0.2.212, which is released just about a month ago. I'm running this version in here. So in Bicep, with the latest version, they introduced this target scope, so I can actually deploy that to subscription management group, tenant, and resource groups. By default, if you don't specify target scope, it's targeted to the resource group. Because I'm creating a resource group as part of my template, so this template should be targeting on the subscription level. Therefore, I'm setting the target scope to subscription, right? And then I have multiple parameters defined. And because I'm not generating the username, the VM passwords in the Bicep code. So I need that to be passed in, right? And also there's no way I can retrieve like Terraform. I can retrieve the current ID of the logged in user. So I rely on that AAD object ID to be passed on, so I can create a key vault access policy, right? Then I have various variables defined, which is equivalent to the locals in Terraform. Then I'll create a resource for resource group. So if you look at the resource group, this is the first part is the resource type in ARM, and then for every resource you need to define, you put a symbol, and then that's the API version that you need to do. You need to specify. So this is something that Terraform is hidden away in Terraform, but in Bicep you have a choice to specify whatever resource, whatever API version you want to use. The good thing about this is if the tooling, the extension for VS Code, you can actually, IntelliSense actually prompt you, say this is the latest one, and then you can just pick one from here.
Well, I think that's one first big difference here. In Terraform, you combine all the resources in one provider. Means that if you update the provider, you're updating all the resources.
Yes.
You understand? And maybe that provider is calling, the latest version of API or Azure SDK.
Yeah.
And here you can have a different version per resource type.
Yeah.
I think, and even in maybe different modules, you could have different versions being used. I think that's
so
because
normally
Terraform is all guided by the provider.
Yeah, so normally what we do in Terraform is when we define the minimum version of the provider you want to use, right? So this is, for example, if I want to create the Sql VM, I need to look up, say, when was the Sql VM resource or that particular property was introduced in Terraform, and then you use that as a minimum version. But as we all know that the version, the Azure RM provider has a release cycle of every week. So every week they will have a new version introduced. So we can't guarantee that what you deploy this week in Terraform is going to be the same as it's going to have the same behavior if you deploy that a week later, because the provider version will change, and then you really need to go into the Terraform provider and see what's been changed. If you see something, some different behaviors, this is because this, right? And then it's not going to be the same every time you deploy, because if you don't have that, if you don't have the latest version, it's going to pull down the latest version. Okay, so when in here we have more control, we define exactly what API version we're going to use for each resources. So something that people been comparing when people talk about Terraform, say how good is the modules, and you can have different modules. So you can write, there's so many modules out releasing in the community, or you can write your own modules to deploy, so you can hide all the complexity away from the people who want to do deploy resources. Some modules have been recently introduced in Terraform, in Bicep as well. As you can see that I defined a module here, and then that's just pointing to a locally stored Bicep file, which is in the same directory, but you can point that to a URL as well. As you can see, it's really new because that the tooling hasn't been updated. It's still showing me this error, but it's actually implemented and working. So so I'm pointing that to a app.bicep though. So everything I'm deploying here is actually defined in app everything within the resource group, right? So I have more parameters defined in this app.bicep file, and I have more variables where I define the variables for the data disks and the variable for SQL configurations. So as you can see, this is pretty much the same. The differences is very minor. Like in Terraform, you use an equal sign, and in here you just use a columns. So and in here you use double quote. In Bicep you use single quote, stuff like that. But and I have SQL disk config. If I do something, because there's no separator for the array volume, so I need to break that into different lines. But yeah, as you can see, the syntax is really similar. And then I start deploying the resource for key vault. So the ARM resource type, again, the API version, and then have the access policies and network HCL, on-prem maybe. One thing you can see is that this is probably not a good example, but if we scroll down, I'm creating same as the resources that for the for the keyboard secrets. I'm creating the network interface, the NIC, and the virtual machine. As you can see, the virtual machine, this is inherited the payload. This is the structure for this particular resource in ARM. So whatever the if you look at the template, the documentation. So this is the JSON payload for that particular ARM resource. Bicep inherits the structure, the object, the class structure for that particular resource. Whereas in Terraform, you can see that they actually flatten it out a little bit. So it actually doesn't reflect what the resource, how the class will look like in ARM. So it's a little bit different, but yeah. So then moving to the Sql Vm. This is something that I couldn't do in Terraform, which is creating an automated backup to a storage account. Therefore, I'm creating a storage account in Bicep, but I'm not creating that in Terraform because there's no point. And then for the SQL disk configuration. In the SQL disk, so we have this, in the VM, we have this dynamic block for the data disk, where in here, for the data disk, I'm simply passing the variable here. So passing the array, as long as the array is, it contains all the informations, right? I have this create option empty, and I can just pass directly in. I don't have to do this dynamic block or something similar. I just pass that straight in the VM. So then I create Sql Vm, have the storage configurations, which is equivalent to here. Have this configured disk type as new, the data disk setting, log disk, and tempdb settings, and then I have the output for this particular module, right? And the output will be passed that to the main Bicep file, and then I can use that for other stuff. So in order to create a VM disk extension after the VM is created, what I have done is I create another module. It basically will become another nested template in ARM template. Something that similar to this block, which won't work in Terraform, is basically it's the same resource types with the same name. The only difference is that we'll have the same payload as what we pass on to for creating the Sql VM initially, and then we only need to pass on the license type. That's mandatory, but the most important thing is the extension, the disk extension. So when we create a Sql VM, firstly is data disk type is new, but now it's an extent, and then I create the longs, the addition, the longs that we need for the SQL data disks. So this is something that I can do in Terraform, in Bicep by using two modules, because they're not defined in the same ARM template, and then I have in here I have to manually define a dependency. So this one, the disk extension won't run before the main template, the main module has been deployed, and I'm using also using the output for the data for the VMs. The output for the main app module to pass into here. So. And then I have the output for the main template in here, which in Terraform I have deployed, is defined in the output. So the other thing is that in Terraform you can, as long as you can break up your pattern into multiple files, as long as they're in the same folder. Terraform is going to consolidate and then combine them together. Whereas in Bicep, you kind of like you need to put everything in the same file, just like how you used to do things in ARM. So what this one?
How about looping? I don't think I have shown any for each or count.
Yeah, so I was going to get to that. There are things that you can't do in Bicep at this stage. Looping hasn't been implemented.
Okay.
There's an issue that created in a Bicep repo, and they say it's going to be, I think, somewhere in January, if I remember correctly. So no looping right now, and also no nested child resources. For example, when you create a keyword, you can actually define. I think you can actually define secrets within the keyword resource, or you have, for example, if you create a or another example, if you create a SQL pass server, you can define SQL databases as a child resource. This is another scenario that it doesn't work in Bicep right now. They still, if you look up the issues that in the Bicep repo, they're still debating whether how the language should look like. So that's yet to be implemented.
I have a question on this Bicep. The order is important. You have to create like one resource before the other, like on the code, because you told we can't split the files like in the Terraform. But can we alternate the order, or the order is important?
No, it's not. The order is not important. Similar to Terraform, you don't have to create them in order. I'm creating this in order to show you that the logical flow, right? But for example, obviously that this Sql Vm resource will depends on the VM needs to be created, right? So so the name, instead of calling VM name, which is a variable, I'm using VM.name, which this VM represent this resource. Name is the output of this resource. So as long as I'm using the output of a resource as a parameter of another resource, it will automatically generate the depends on block when Bicep generates the ARM template. So this is the ARM template it generated. So this is the VM, Azure VM, and then this is the Sql VM. And in the Sql VM, you'll see that it automatically generated depends on. Yeah. So it depends on the storage account, because I'm using the storage account for the Azure for the automated backup, and I'm also it also depends on the VM. So this is something that I did not specify in my Sql VM, only because I'm using I've referenced the output of the other resource right in here and here that will automatically generate the dependency for you.
No, I have another question as well that I remember here. There is no one big thing on Terraform is like module, the registration for the registry for the module.
Yep.
Where Terraform Enterprise or Terraform Cloud, you can have these. Is any plan? They haven't had anything about how they're going to, let's say I develop a module for VM and I want to share this module between multiple.
Well, you can just put in a public Git repo and then reference that way.
Okay, it has to be a public, at the moment, it has to be a public.
Well, it has to be somewhere like where the Bicep will get to it, right? So when you do the Bicep build command, which builds the ARM template, you will need to be able to read. Actually, no, it doesn't have to be public, as long as where you do the build can get to that file. But later on, like when Microsoft when they are able you to directly deploy the Bicep file, then that would be a problem if it's a private repo, and that comes to the problem we have right now is how do you reference another template like a nested template in your ARM template. If the ARM engine can't get to it, then you can't do that, right? It has to be public. So
yeah, I think that was one of the main reasons that people never really used, nested templates, because you have to put somewhere and you have to have public reference, and that was a blocker. Then we don't want to bring the same problem here.
Yeah. So
and versioning as well. Have different version control for. I think nested template you can have a version. I'm not sure how you can have version here on the module on Bicep.
Yeah, I'm not sure yet. I haven't looked into
That's something that's a work in progress.
I don't know. I haven't checked.
Yep.
Yeah, but if it's a Git repo, then you can have different. You can reference different commits, right? So yeah, I don't know. I don't know at this stage.
But it's a work in progress. I think that's the point. It's a work in progress. That thing is improving very fast. I can tell you. Like, I saw that 3 months ago or more, and then they discuss all these things, and I can see now that most of the things implemented.
Yeah. So you see, the last commit is only 5 hours ago. So
yeah, I think .3 will be coming with a lot of new things. And then, but looks very promising, so far, I think.
Yeah. So the other thing I want to point out is that initially my plan for this demo, and I think this is probably going to be other use cases, is that there's a public API I can use to get my public IP. If I just hit this API, I will return my public IP address. So this is very useful if I want to in here or want to define what IP I need to whitelist for keyboard, so I can actually create secrets in. So my plan was to actually invoking this API to get my public IP by using a provisioner in Terraform called local exec, right? But the limitations on how we can consume the output of that provisioner for to use in other parts of the template. I've done this in the past, but it's not pretty. There's no native way you can actually consume the output. What the best that you can do is you need to save that into a temp file and then use another file provisioner to read the content of the file and then get that in. So I gave up. It's too complicated, and for this demo, I didn't have time to do that. But there's a limitation in Terraform that if you want to run a script and get something and then use the output for on other part of the template, that can be really complicated. Although you can't do that in Bicep, but I think my argument is that since Terraform is something that cross-platform, you can do many different things by using different providers. So it's not fair to compare, to compare a Terraform with Bicep and say which one's better, because Bicep is only a domain-specific language for ARM, right? So if we want to do a fair comparison, and I hope this is the case, that when you create a ARM template or a Bicep template, that should be only part of a solution. That should not be the finished product. That should not be something that you use to deploy stuff directly to your environment. So what's missing? The missing piece obviously is a CI/CD pipeline, right?
I think the question is, before the pipeline, if you want to get started on your machine, on the terminal, what you need to install? You need that Sql, you need the extension here for the VS Code.
Yep.
And you need to download something. What do you need? Just like a command line tool?
Yeah, so it's a command line tool. It's like it's like Terraform. It's just like I'm running that on my on a WSL, right? For Bicep, all you need to do is to there's just one line. It's basically just one file, one executable you need to download, and to get that started in here. So there's basically just download that Bicep file and then just install it. Put that somewhere on your on your VM, and also and it's the same if you want to use that on Windows. There's a document, there's a doc folder.
And the main command just like a Bicep build in Bicep.
Yeah. Yes, it's somewhere in here. I can't remember.
Okay.
But yeah, there's in this repo, there's got the instruction on how to install. For example, I've got here. Sorry, in here. What I need to do is just go bicep build main.bicep file, right? And what this one does, because no error, so you actually create a this main.json, which is the ARM template. So if I just delete that file
and generate again,
and do it again, and you see that that's generated. So basically, yeah. So Bicep, you can.
That's just the beginning. I think they're going to improve to kind of find a way to apply, to
that's
build
on the
and
roadmap.
apply all at the same time.
Yep.
But it's not done yet, and that's why you come with a CI/CD to do all those builds and then apply the ARM templates as usual.
Yes,
that's what your pipeline is probably doing, correct?
Yes. So they in the repo it has a sample pipeline for you to build the Bicep file and then deploy the ARM template. I think this is a format for GitHub Actions. So I've translated that to a Azure Pipeline. So in Azure Pipeline, what I've done, obviously, I need to generate a random password. So I'm using I'm running this on a Ubuntu agent, Azure Pipeline agent, but I'm using PowerShell to generate the 2 passwords and put that in a pipeline variable, so I can use that later. And then also to get the current IT, which is the same like using that in Terraform, you have this data block to look up what's the current user ID. In here, I'm using a PowerShell command to do that as well. And then I'm using what if, which is similar to Terraform plan, to see what will happen if I deploy this template, and then I'll deploy the ARM template that Bicep has generated. One thing I want to point out is that although Bicep right now you generate template, but for the parameter file, you just define that. They haven't done anything for the parameter file yet. So it's as you can see, it's in the JSON format, right? So it's an ARM parameter file. So you can't define this parameter file in Bicep right now. That just purely just our ARM parameter file.
Well, Tao, if you go back on the pipeline, where are you doing Bicep builds?
So
you doing the build there or not yet? Or just
I'm doing build here.
For each object.
In here.
Build ARM template.
Yep.
Okay.
So I'm installing Bicep first.
Yeah.
Right. So this is basically this is the command for Linux. So I'm downloading this file.
Yep.
And change the permissions and make it executable, and then move that to a location. All right.
Are you keeping the same way that the GitHub Actions is done on the documentation?
Yeah. Yes. Correct. Correct. I'm doing the same way. I'm just converted that to Azure Pipeline.
That's great.
Yeah. One thing I want to talk. The other thing I want to talk about is that the generating like a random strings. In ARM, there's an option to generate. There's a function you can use to generate. Let me see. Generate random strings. Let me see where you can find it. It's somewhere in here. I think it might be in here. Name suffix. Yeah. So I have this unique string function to generate a random string, but the problem is it's unique. It's not as long as the input parameters for this function is the same, the output will be the same. So it's unlike being random. You won't have different output every time. So in order for me to generate a different name suffix every time I execute the template, what I do is I pass in the resource group ID, right? Was the first part. You can pass on multiple parameters in here to generate the string, and then the second parameter is the timestamp, because every time when you run this template, it will have different timestamp. By doing so, I can guarantee you that every time a different suffix, a different string will be generated. But however, because this is a predictive behavior, right? So this is good for you to generate a random string that's not considered as a secret, but because it's not random, it's unique, I don't recommend that using that to generate the password. Therefore, I'm not using that for the password generation. I actually pass that, put that in a pipeline to use a PowerShell command to generate the password instead of using this unique string function in ARM. Yeah, so that's pretty much it. What I want to cover. I hope I cover everything. All the findings I have for now, based on my experience in Terraform and the Bicep so far. George, Fernando.
I think it's great. Just keep in mind, Bicep's a work in progress.
Yeah.
There's a lot of more things coming, like you said. These missing parts there, but you already have module. We have a lot of things that allow you to deploy many things already. That's
if something is not working, and just look up here, like in the issues, it's being actively being worked on. And if you see there's an issue that you found an issue that's not been defined in here, submit one.
Yeah, but it's not a production-ready product yet.
Yeah, don't deploy that to your production environment right now.
Don't deploy, just play. There's a version coming that's going to start giving support, but will be for early adopters.
Yeah, you talk about, for example, you talk about the modules for these versions. So there's already a issue created, right? So it's something that
Yeah, but it's moving fast. I think next 3 to 6 months will be.
Yes.
Version we're going to have a version that will be supported, but keep in mind that's for early adopters, and you have to be keen to be changing, updating your code as required. But there's a lot of goods there.
Yeah.
And thanks, Fernando. Any question?
Yes. When the Bicep will be ready to go to in production? Do you have any date or?
No, I don't think there is any date yet.
They have a rough estimate. I can't remember. There's a YouTube video the product team has released back in November. They talk about the progress they made so far. They mentioned something. If you go to YouTube and search for Bicep, I'm sure you can find that they published that on YouTube.
Because it makes the life who works with ARM templates better. It's so easy.
Oh yeah,
ARM templates.
Yes. Yeah, as you can see, if you are familiar with Terraform, you should have no problem picking up Bicep. The syntax is really, really similar. What's different is the terminology, right?
Right.
Parameters versus variables and so on.
Yeah, there's still a lot of edge case to be, work on, but
yeah,
is moving fast. And when you see version 0.3, I think that's the first version they promised some kind of
have some kind of support, right?
Support before that's not recommended.
Yep.
And from 0.3, there'll be the beginning, of some support, but still early adopters.
Yeah.
But you'll be more feature complete, and be less, breaking change from 0.3, but still can happen. But they're going to support if that happens, and that's the promise. But you have to watch the announcements, and it's something that I recommend for people to start looking. We can make another video, later when you have more progress in 3 months or maybe.
Yep.
And thanks, Tao. I think I appreciate really good. We followed that.
We'll talk about looping, right? And just found that the issue is says looping. They're hoping to support that looping sometime in Jan, and we're already like midway. So hopefully we'll see that looping capability soon in Bicep.
Oh, cool.
Yeah. Yep. Follow Alex. Alex, that's the guy that's developing this whole thing.
Alex is the PM responsible for that. So just go look him up on Twitter. He's got a lot of good stuff.
Thanks, Tao. I put some links as well on the video on the YouTube
I will share the template with George. I just have to create a brand new repo, and then I'll share the link out. Make sure we'll have that ready by the time this video is released.
Good. Thanks, Tao.
Thank you, Tao. Thank you, guys. And follow Azure. There's a lot of videos there, and keep following us and supporting us.
Thank you.